Now, this is very much important. This UPS we use, okay, online or double conversion UPS it is called. Why double conversion? It converts it into DC and again it converts into AC. Okay, that is why it is called double conversion. So first thing it uses is rectifier. We are going to see in detail how rectifier exactly converts AC into DC. Okay, we will see exactly how it happens in detail. Inverter again converts that DC power to AC power, and that is why we have seen in last module, that is why it conditions power. Okay, so logic, AC is input, then rectifier converts it to DC charges battery, then inverter recreates clean AC output. It recreates, it is being created. So we can give him an input that this type of power, this is the waveform, this is the parameters, I want this conditioned power. Conditions we can put and it can recreate it for us. That is the biggest advantage. We are creating it as per our requirement. Simple. Load is always on inverter output. See, very important. If load is always on your created waveform, then you are safe. Okay, no disturbances, no harmonics, no frequency variation, no voltage variations, because you are creating it as per your requirement. Inverter. Never on raw means. It is called raw because it is not conditioned. Everything is conditioned, filtered rather, I say, by this inverter. Raw means zero transfer time because it is always on inverter. It is saying always. Then complete isolation from input power quality issues. Complete isolation because it is not using it. It is using it as an energy source. Okay. It is taking that energy, converted it into DC, then it is storing same time. At the same time, it is putting it, is giving it to inverter, and inverter converting that energy power into desired waveform. So it is completely isolated, raw power. So it is not dependent on raw power parameters anymore. So complete isolation. This is the gold standard for critical loads. This is the gold standard. Okay, and this is being used everywhere, I'm telling you. Now we are going to see in detail how this rectifier, inverter, STS, all these equipments, how exactly we'll see the diagrams, and I will show you how power conversion is happening in detail. Okay, next module. Why DC link is the heart? Okay, the DC bus typically 400 to 800 volt DC link. What is DC link? Is where battery and rectifier meets. See, battery is there. Okay, I'll show you the block diagram. Wait. So we'll just understand the basic block diagram of UPS. So mains is coming in, then it is being converted from AC to DC via rectifier. Okay. Then our DC bus, then it is giving that DC to battery for charging. Then same time it is providing that DC to inverter, same voltage level. Okay. Then in inverter, this DC is converted into AC. Okay. And then it goes to load. Now here we have a static bypass. Static means it does not have time. Static switch we have seen in briefly. Okay. It will not take time. It doesn't have any moving parts. It's very fast. Electronic equipments like IT loads will not come to know even it is switched, okay, to other load. So if anything happens to this, like rectifier is not working, inverter is not working, battery is dead, in that case this will switch it to the mains. Okay, rather than switching it off entirely, it will put it onto raw power or EB power. So that is static bypass. Okay, so this is briefly the block diagram of our online UPS. Now DC bus, we have seen the bridge between rectifier and battery. So this line, even this, because this will be at the same voltage level, is the DC bus. Now we will see in detail what is DC bus exactly. The DC bus, typically 400 to 800 volt DC, is where battery and rectifier meet. We have seen in block diagram. It's the stability anchor of the entire system. Okay, because it is at the center. Battery provides energy storage. Okay, rectifier provides continuous charging. Then inverter draws from the stable DC source. Okay, any DC link voltage fluctuation indicates critical issues with rectifier, battery, or inverter. It's very much important because it is connecting to all this side: rectifier, inverter, and battery. All these three things are connected by DC bus. So in terms of monitoring, it becomes very critical. We should always monitor, as a facilities manager, we should always monitor this DC bus voltage, because if any one of these three behaves differently, this belt voltage, see, critical issues with rectifier, if any voltage fluctuation on DC link, it indicates issues on rectifier, battery, or inverter. So if you want to understand the issues on these three things, you need to monitor the DC bus voltage. Okay, that is what it is telling. FM must monitor DC link voltage closely. That is why I have highlighted it closely. It's the best early warning for UPS health degradation. Okay, as a FM, we should know. I'll say now it is a era of IoT devices. So you should have the DC bus voltage monitor continuously on your BMS system. Okay, so that you have the behavior pattern of it. Okay, you should save it. Easily you can connect this UPS to your communication channel. Okay, by SNMP protocol or backnet protocols we have seen. SNMP protocol is used generally in UPS, that can be connected to your IoT or BMS service devices, and then you can have the graph of it, and then you can put the thresholds for that. Okay, maximum and minimum. If anything goes wrong, it goes beyond maximum or beyond, it comes down beyond minimum, then it should give you the alarm or alert. Okay, on mobile also you get that alerts nowadays. Wherever you have internet connection, you get the alerts. That is why this DC bus is very much important to monitor, to connect, so that you know the health of your UPS system.